Sasha plans to retire in 25 years. She realized that she needs, not he. She needs $1,500 a month. Wow. Should we give Sasha more money? How much should we give her a month? This is going to be easier to make a 4 here. $4,500 a month and plans to live 15 years past retirement. Oh, Sasha. So young. How much should she deposit monthly now at a 6.75% annual interest rate to ensure she, I did it correctly, has enough money in 25 years? That's a 4 right there, not a 1. 4. There we go. If you get done writing it, think about what formulas to use and in what order. So we need a formula pre-retirement and a formula post-retirement. Yeah. So let's start with the post-retirement because that's where we know the number. We need to figure out how much she should have at retirement. So how much should be sitting there at retirement so that she's able to take out $4,500 a month. What formula is that? So one more time, how much she should have at retirement. So what lump sum she should have at retirement so she's able to take out $4,500 a month. What is it? Not future value. Of an annuity. This is a present value of an annuity. So remember, a present value is the lump sum she would need right at retirement so that she's able to take out $4,500 a month. The reason it's of an annuity is because she's taking out stuff monthly. If she was just taking out $4,500 and that's it, it'd be the present value from 5.1. All right. So how do we figure out what formula do we need? One more time? Well, that'd be something else. The sinking. That's it. We need a sinking fund. Because this formula will tell us how much we should put away now to ensure that we have enough money in the future. It's not to say that you can't use future value for before retirement and amortization for after retirement. You'll just be making it a little bit harder because it's not set up to solve for those things. So sinking fund, present value and annuity is set up to solve for the present value. But if you use amortization, you'd have to flip it around to solve for the present value. So since we know the number for after retirement, we're going to start with present value and annuity. And I don't have to explain this picture to anyone, do I? Thank you. So present value, bucket sock, is equal to the payment PMT times, let's see, what is it? 1 minus the quantity 1 plus, is that this one? Let's see, we're doing 0.0675. Sorry for the squishiness here. A month to the negative. We're doing this 12 times a year for how many years? 15. 12 times 15. Sorry about that. So that exponent is negative 12 times 15. Is that 180? 180? All over 0.0675 over 12. 526. Good. 508. 526. and 60 cents. So she needs to have that amount of money, over $500,000, by the time she retires, so that she can take out $4,500 a month. So now we have to figure out what she should be putting away now. I'm getting verklempt. I love this problem so much. How much she should put away now per month in order for her to have that $500,000 when she retires. So even though it's not technically a debt, she's saving up to have $508,000. Questions on that? Okay. So now we're going to do the sinking fund formula, which starts off as PMT equals, in the future we want to have 508, 52660. We're going to have 0.0675 over 12 over 1 plus and how many years are we doing this one for? 25. So 12 times 25 minus 1. Again, all of the formulas are being provided for you. You just have to know when to use them. However, do not succumb to user error of copying the formula incorrectly on your test. So a lot of times, the negative on the exponent may disappear, and there goes the whole problem. You should have a thought process as you're doing these problems of, does this answer make sense? If she's having to put away $20,000 a month, something went wrong. It's probably not going to be the answer. Now, to get $500,000 in 25 years, that's going to take some doing, but it should at least be reasonable. So please be careful as you're doing these problems. And also, since I cannot see what you're putting into your calculator, become comfortable with how to type this in your calculator. What'd you guys get? That's not too bad to be able to have $500,000 when we retire. Hooray. So she puts away $653.01 a month for 25 years. She'll be able to take out $4,500 a month for 15 years.